Okay, so today we're going to be using vertex form to help solve for X-intercepts or the value of X. We know this as our vertex form, but we haven't done much algebraically with it up to this point. We've just kind of used it to draw graphs and then transform them up and down, side to side, make them thinner or compressed. Right now what we have is we have a vertex form. Okay? And this question is going to ask us, what are the X-intercepts? Okay, so X-intercepts. We're used to having quadratics in a much different form in order to find X-intercepts. Anyone remember what that's called? Yeah, we usually start with standard form. What form are we in right now? Vertex, that's right. So we're in vertex form. What we want to do is we want to go to standard. What is the process called to go from vertex to standard? It's the same process that we use when going from factor to standard form. Simplifying or expanding and simplifying is usually what they say. Okay? So we're going to write down the word expanding right now. So we need to expand this. So we'll expand our vertex form. Now our vertex form here is our f at x. When this is expanded, what this really says is x minus 5 multiplied by x minus 5, because it was squared, minus 36. We're then going to FOIL, which I'm going to do a little quicker than you guys are used to. This is going to become x squared minus 10x plus 25. Okay? If you had trouble with that, take an extra step and go through it. And then from there, I just have to collect my two like terms at the very end of this. So we have our x squared minus 10x. And what are we going to get? Negative 11. Great. So we are now in our standard form here. Now, does this give us our X-intercepts? What are they? We can't tell yet. What do we still have to do? Factor, that's right. So we need to put this into factored form. Okay? And to go to factored form, we use the process of factoring. We know that. So, because there's an a value of only 1, we really just need two values that are going to add to the middle and multiply to our last term. And I can tell you very quickly, anyone know what those are going to be? What are they? 1 and 11. Now, is it going to be negative 1 or negative 11? That's right. We need positive 1 and negative 11. Okay? And again, if you're not sure, go through the actual process of factoring to see how we got that. Okay? So now that we have that, to find X-intercepts, we have to set our Y value, which is f at x. We have to set that equal to 0. Okay, now this is very important because this is very similar to what we're going to do when we go to solve this using vertex form. So we set our y equal to 0 in this question. And from here, what do we normally do?
Separate the equation.
That's right, we got to split our equation from here. So we split our equation, we're going to get 0 is equal to x plus 1. And we're going to get 0 is equal to x subtract 11. Okay? Which means our two x values are going to be negative 1 and positive 11. Great. So we've done that now. And just to go full circle here, how would I find the vertex? Now I know we started in vertex form, so let's verify one quick second. What is the actual vertex when looking at this vertex form? That's right. The actual vertex is positive 5 and negative 36. So let's verify that we haven't made any errors going through this. We have our X-intercepts. How do we find the vertex?
Negative 1 to 11.
That's right. So we find the axis of symmetry by adding the two values together, which is negative 1 plus 11. And we divide it by 2, which is going to give us what? 10 over 2? 5. Does that make sense for an x value? Yeah, that's exactly what we got as our original x value of the vertex. Okay, so we have our x value to be 5. We still have to find our y value. What do we do to find the y value here? We plug the x into the original equation. I can plug it into either the factored or the standard form. Okay, we'll plug it into our factored form here just to keep it simple. So let's plug it in. We have f at 5 is what we're solving in function notation. Our x value will be 5 plus 1. And our other x value will be 5 minus 11. We're going to multiply those values together. we're going to get 6 multiplied by negative 6, which is negative 36. And is that exactly what our vertex form told us our vertex was? Okay, so that's kind of going through the entire process all in one step. We started in vertex, went to standard, standard to factored, and you could say back to vertex. But let's say we have our original vertex form again. There's actually a much faster way to find our x-intercepts here. Okay, we have x minus 5 squared minus 36. Now, in vertex form, or actually let's talk about standard form to start. In standard form, we have two variables with different exponents, so we have to go through that process of factoring, and the splitting becomes very important here. Okay, we get two answers. In vertex form, we actually only have one variable that's going to be unknown. When we only have one variable, that's very ideal for isolating. Okay, so what we're going to do is we're actually just going to isolate x and solve. So for an x-intercept, what does our y have to be equal to? 0. F of x represents y, so we're going to set this equation equal to 0. 0 is equal to x minus 5 squared minus 36. And we're going to work on just isolating our x value. Now, when we isolate a variable, we usually use something we talked about in elementary school, reverse bedmass. We normally go through the bedmass operations, but in reverse bedmass, we take what would normally be the last thing to do, and we would do it first. So the last thing we'd probably normally do in bedmass would be this subtracting of 36. We're going to move that to the other side to start. What will it become on the other side? That's right. We're going to have positive 36 is equal to x minus 5 squared. Now, sometimes there's an a value here. That would normally be the next step. So our a value is technically 1. Let's say I want to cancel out that 1. In many other examples, maybe we have a negative a, 3, a fraction. In order to do that, we would divide both sides by that value. Now, in our case, does that change anything? No, it doesn't change anything. But just keep that step in mind in case you do have an a value that is a number other than 1. You will have to do that step. Okay? So we get 36 is equal to x minus 5 squared. Okay. Bedmass, normally it's brackets, then exponents. So because we're reversing that, let's work with our exponent. What cancels out a squared value? What would be the opposite operation? That's right, the square root. So we're going to square root both sides of this equation. Now when we do it on the right, the square root and the squared cancel each other out. So we're left with x minus 5. Now this is where we get an important detail. What is the square root of 36? 6. But you only give me one answer. So there's actually 2. There are 2 numbers that multiply to 36 when you multiply it by themselves. We have positive 6 and negative 6. So there's actually 2 answers here. So we usually represent this by saying plus or minus 6. Okay? Now at this point, this is where we're very similar, and I'm going to scroll up to where we did our splitting before. Oh, there we go. Don't know why that happened. Okay? What we're going to do is, again, we're going to split our equation, but this time it's not equal to 0. It's equal to either positive or negative 6. So we have 6 is equal to x minus 5, and we have negative 6 is equal to x minus 5. Right? Because we have 2 answers that get us to the square root of 36. When we move this over, this answer will become x is equal to 11. And when we move this over, we're going to get x is equal to the value of 1. If you're not sure how I did that, I just moved the 5s over and equated all in one step. And are those the exact x-intercepts we had before? No, something's off here. What do I do wrong? Sorry, this will be negative 1. Negative 1, right? And are those the exact intercepts we had before? Yeah, negative 1 and 11 is exactly what we had before. So we can actually solve using vertex form for x-intercepts very quickly. We don't actually have to go through that expanding. We can just go right into setting it equal to 0 and solving